So I'm actually just gonna make a mini video today because I've been doing my weekly vlogs, which is so fun, but low key, I don't really like them. I think I might still continue doing them, but I think honestly, like just having like videos are just better. I don't know. You guys know that my seriousness with this vlog channel is not there, but today it's Wednesday. Oh my goodness, you guys. I'm about to have a heart attack. So it's Wednesday, and Wednesday, I think September 16th or 17th, I'm not sure. Doesn't matter. I am introducing you guys, my parents. I have my dad here. Can you say hi? Dad. Dad. That's the mic. Oh my goodness. Dad, right here's the camera. Say hi.
Hi.
Where are you from, Dad?
My mom.
Guys, so I actually get my humor from my dad because my dad is the funniest person after me. But, Dad, where are you from?
Guatemala.
What city?
Chiquimulilla.
And then this is my mom, Perla.
Hi. Originally from Mexico, but I was brought to the United States when I was 2. And I've lived in Sioux Falls since 1998.
So I am here teaching my parents the physiology that I've learned this first unit because I was just talking to my parents and I was like, Dad, do you even know what a cell is?
Yes.
Dad, when did you graduate school?
I don't remember because I didn't.
My dad didn't go to school. He went to a village school because he grew up in the mountains of Guatemala. He finished.
That's my graduation, ninth grade.
So I get my smartness from my dad because I graduated in 10th grade. My dad graduated in 9th grade. But let's just say it's because that's when his village school was over. So I'm going to give them a little lecture of what a cell is. So we obviously know there is the cell body, which I'm just going to do a little basic. There's a cell body.
You have a question about that?
No.
In the cell body, Dad, there's a neuron. There's a nucleus in the cell body, right? That is the brain of the cell. That's what controls everything. Then there's stuff like the mitochondria, which is the energy. This is a simple cell. There's a lot more things in the cell. This is like a eukaryotic cell. But within the cell, Dad, there's something most importantly called the cell membrane. The cell membrane is on a eukaryotic cell. Those are human cells, if you will. I mean, a lot more than humans. But this cell membrane protects the cell, allows things to go in the cell, especially does not allow things to go into the cell. But this is basically what's keeping you alive because you have your DNA in there. It makes proteins. It keeps you get energy, allows you to think. But what I've learned, this is simple, okay? This is what allows your body to move. I mean, we could talk about transcription and translation, but we're not talking about that today, okay? No. Within a cell, I'm going to do this kind of again. You have so the camera can see. Oh, I don't have black. You have your cell.
That's one.
But you have to understand, in order for that cell to happen, there needs to be like bridges, channels, Dad. Stuff to allow things to go in and out. One thing, so there's a channel where you can easily just let it go in or you can let it go out, either or. So there's channels that need energy for it to work. So some channels work like this. If this is the cell, some of them work like that, where you have to allow it to open. So whenever energy is produced, let's say this is an energy. When that energy is working, that channel will go like this and allow whatever is going in from the outside of the cell.
It's going out at the same time.
When that energy closes, whatever is going out will also come in. Do you understand that?
Yeah.
It's kind of like a zipper.
What happens if you drink a Red Bull?
The student has a question.
What about if you drink a Red Bull?
So my dad is asking what happens multicellular form, what happens when you drink Red Bull. But here's the thing. So the chemicals in Red Bull aren't going to necessarily affect the cell, but you are right. Whenever your food, whatever you bring into your body, will help either not help or help your cell growth, because you have to give your cell the right nutrients. So that's why we have to have our macro and micromolecules. We have to reach our macros daily. That's not just for nutrition, but that's for your cells. It has that cell, but it has a lot more because it has dendrites. Dendrites are basically like fingers, Dad. They help attach and connect. So when I say you have underdevelopment through synapses, these dendrites will form to make an axon hillock, an axon. This type of axon, Dad, will form and get another neuron. And when that action occurs, when this connects right here, when these two connect, Dad, it makes this stronger and it starts the growth of this.
Another one.
And another one.
All right.
This type of growth, what I'm talking about, like babies need that type of growth. They need synapses to occur for their white matter to grow. That's in your brain. The white matter is your development. You don't need gray. You start off with gray matter. You don't need gray matter because you need growth.
If this axon is not doing this work? It's not doing
So I'm going to show you how that axon is producing work.
If that's gonna stop right
If
there,
that stops right there.
doing that,
You know, I'm going to show you how it stops right there. That's a great question. My dad's wondering what would happen if an axon didn't work. So just to show you this, you have to have graded potential. So our body moves, right? You have different types of brain cells. So for my body to realize that, like look, my body, right now it's not moving, but my brain has to think of, I want my finger to move. So my body has to sense my finger needs to move, and then it will get that knowledge, and then it'll move. So let's just say this is a nail. Do not show my foot. I do not want feet pics taken of me. Okay. I'm just starting my channel. Let's say this is a nail, and my body, let's say I step on the nail, gets the response immediately that something's sharp. This action right here, the synapses, will help get the information from my bottom of the foot, reach it all the way back to my brain, so my brain has the signal to say, get your foot off. But with those type of movements, Dad, you have types of stimuli that will give the information to the brain, and you have different type of stimuli that will do the motor functions. Do you understand that? So, but for that to occur, you have graded potential. What graded potential means is that for those actions to occur, you need a building process. So I'm going to make a diagram for you. I'm just going to show you how the energy is going to simply work. So you have energy, Dad, right here. This is time. Over here is time, and over here is energy. You know how like lights use like watts? You know, watts? And they use voltage.
Use a HO or what?
Yeah, water is H2O. That's right, Dad. Water does use H2O. Good job. But you know like volts? We're going to use millivolts. Like it's energy. So your cells need to get enough energy for this type of signaling to occur. So your cell, you know how I said there's energy in it and like there's a brain? This cell has energy because it's producing protein and it's making enzymes which will produce energy to you all the time. It's doing this literally by the millisecond, Dad. Not even. It's doing this probably in the span of 1 second. It could all be produced. Not an entire formation of the cell, but the energy passing. So whenever you test the amount of voltage in a cell, Dad, it tests at negative 70 millivolts. That's the resting membrane potential.
You're definitely gonna be a doctor.
This just means that this is the average potential that the energy is stored in the cell. And so right here, I'm gonna label this as negative 70. Over here, negative 90. I'm gonna put 0 and 30 millivolts and 55. So your cell is always
Making hundreds.
always resting right here. But remember how I said the graded potential? It's going to use EPSP. That is I can't remember what the E means, but that is exhibit. I think it's exhibit or excited. Excited presynaptic potential. I'm pretty sure that's what the E means. So your EPSP is going to allow for somehow through sodium, Dad. So you know sodium like salt. You know how we have to have salt in our diet. Sodium and calcium. Calcium is good for your bones. You know how you have calcium? That is going to allow for your cell to somehow get growth. So it will get enough growth, and it's trying to reach this minus 55 millivolts so it can have a reaction. So it's going to try to continue to growing. And once it gets enough sodium and other types of ions, we're not worried about the other ions. We're specifically talking about sodium. Once it gets enough sodium, it's going to allow your cell to accelerate, and this is going to depolarize the cell. So your cell Side note that your cell, right here, you know how it has energy? It also has, when we're specifically talking about potential, it's because it's positive on the outside of your cell, Dad, positive, but it has negative potential on the inside. Inside your cell is negative. Why? Because of the channels. Remember we were talking about the bridges, how things go in and out? There's channels that go in that are leaky, so they're always open. So something can always go in and out of those channels. There's channels that will only open with energy, gated ion channels. There's passive and active transport. And so
Is that in your head or where?
this all over your body. These are your cells, Dad. You have to understand cells are all over your body. And so your cell is positive on the outside, negative on the inside because of the potassium, the sodium potassium pump ACE ion gated channel. That channel allows sodium to enter in. Yes, sodium to enter in and potassium to want to get out. Whenever that channel works, Dad, you have to see the bridge as this. The bridge has energy, what we call ATP, adenosine triphosphate, to allow, that's the energy. It will allow this, Dad. It will allow 2 sodium in. I'm gonna put that right there, sodium. And then whenever it opens, this is the outside of the cell, Dad, right? When it opens, whenever the energy is activated, look at the board. Whenever the energy is activated, Dad, the pump channel will allow it to open. And when it opens, when it brings the potassium, whenever it brings the sodium in, it also retrieves 3 potassiums out. And when it opens again, 3 potassiums go out. So you see how there's 2 go in and 3 go out? Because 2 go in, since there's two that go in, right? Let's just say the number's at 5. And it's 2 5s, right? Let's get simple numbers. 2 of them go in, so that's now at 7. But 3 go out, so that's now 2. And another 3 go in, that's 10. But now that's at, like -1. See how it's different? You have to understand those type of growths happen all the time. So no matter what, because that pump is always working with ATP as a facilitated transport, your cell is going to be negative on the inside, positive on the outside. When you depolarize, that just means you are making it less polar, less negative. So remember we're talking about the energy over here? When you depolarize the cell, Dad, it brings the inside, you know what it does when this happens? It's bringing more sodium in from everywhere. So it's bringing everything and making it positive. A little too positive. See how it's positive on the inside and still positive on the outside? We're talking about many types of ions here, but right now I just want to focus on the potassium. As I don't even know what the footage is going to look like because my dad's recording. Do you understand what it's kind of getting at right here? Yeah. So I'm going to delete all this. So this type of energy, Dad, this is what's happening within the cell. So remember how I said there's a cell body? And remember how I said there's like dendrites, like fingers? And I said there was channels, right?
Going in, going out.
Going in, going out. So for this to occur, that just means sodium is simply entering the cell. When sodium, so it's kind of getting hard to explain because I didn't explain a real neuron and a glial cell, but you have to understand, Dad, that cells want to attach to each other. And when they attach, Dad, when they attach, that attachment has a ligand gated channel, which produces more sodium to go inside the cell. So this is happening all over your body. But when there's a lot of attachments, when the fingers are attaching to everything, that's when this occurs. And when that occurs, remember how I said the word that started with an A? Do you remember that word that I'm talking about?
I remember the one that started with the E.
The axon?
Yeah.
That type of work will now allow this greater potential to make action potential. A for action, A for axon. This, remember that bridge that I was talking about? Let's create more fingers. That bridge is now what's happening right here. Because when it hits 55 millivolts, negative 55 millivolts, it allows for action potential to start because of the sodium voltage ion channel. That sodium voltage ion channel will allow the axon hillock right here, the axon hillock, to start producing energy. And it also helps when you have myelination around the cell, and when you have the nodes of Ranvier. And so when all this is happening, your body's just producing so much energy, Dad. So whenever this is occurring, it's allowing the growth to form, to get another cell, Dad. That's what it's doing. Now, this cell was already there, but the only thing connecting these 2 cells is this type of energy. Do you see that? Because there's cells all over your body. But they're alone until, you get enough energy for them to connect. So right here, you call this a presynaptic cell. That just means there's no connection. There's no bridge from this cell to that cell. It's presynaptic. Nothing is attached to it. This is a postsynaptic cell, where something's already attached to it. I mean, something went to attach to it. So whenever you get this, it allows for this to grow and reach the potential. And once it reaches the limit of 30, it produces the potassium voltage gated channel, which will allow it to go back down, to repolarize, to make this, because once it attaches, Dad, you have to understand, it can't attach again. So it needs to go back down so this cell can rest
So there's not sodium just coming in. So that can finally rest. It's at a rest. It's inactivated. It's not closed, but it's inactivated. So then it allows potassium to enter in. So remember how I said it was just positive, all positive, and it was kind of getting positive in the inside? Now it's starting to get negative again. Right, good job. You got it. And so so it has to repolarize and go even below the negative 70. It needs to reach even negative 90 because it needs to rest. And once it's rested, it can go back to the 70. And once it's back at the 70, that's when it can start again. But this type of formation, Dad, you understand this kind of concept? I'm going to show you this is the last part of my mini lecture. I'm going to ask Dad, do you feel like you've learned something today?
I did.
What were we talking about? Dad, right here. What?
Don't ask me, Junior. Don't ask me.
What was I teaching you about, though?
I don't remember. No, Junior. I'm not going to explain it. You already teach me. But the cells, once it's here, and it's going to reproduce another one here, and then another one there.
And that form is called...
Is what's it called? I don't remember. Synapses, ¿cómo se dice?
You're really close. It's not synapsis. It's synapsis.
Oh yeah.
Yeah.
Don't remember it.
So, remember how I said there's greater potential?
Yeah.
What's the other type of potential? It starts with an A.
Action
Action potential, right.
potential, yeah.
And that action potential allows what to grow?
The axon.
Yes, the axon is allowed to grow because of the action potential, forming at the axon hillock. Do you feel like you comprehend a little bit of what I was teaching you?
A little bit,
Yeah.
It's a lot.
So did you ever, Dad, when you were in your school village, did you ever learn science?
Not at all, man. I'm just learning it right now.
So have
Just
you
learning.
ever heard of anything like the mitochondria or anything like that?
No, this is my first time.
Yeah.
I'm doing pretty good tonight. I'm doing pretty good.
Yeah. Is it okay if I post this on YouTube?
It's okay.
Do you have anything to say to my vlog, Dad?
Follow me.
He said it, you guys. Follow me on YouTube. Subscribe. Hit that like button. Hit post notification.
Share.
Share and like.
Share and like.
And so I'll see you guys later. Bye.